Okay, this is Kinematics 2, and we're going to go through these problems the way that you need to on your test. So we're going to do the guess method. We're going to pick our equation. We're going to solve for what we want. And then remember, and I hope that this is getting annoying, we are going to box our givens. We're going to circle our unknown. This is a really helpful thing, and I hope that you guys are doing it. So for this first one, a toy car has an initial velocity of 8 meters per second. So we're going to box that. It slows down at a rate of negative 2 meters per second squared over a distance of 7 meters. What's the new velocity of the toy car? So going through it, my givens, the initial velocity of 8 meters per second, slows down at a rate of negative 2 meters per second squared. That's our acceleration, negative 2 meters per second squared, over a distance of 7 meters. So my displacement is 7 meters, and what we want is the final velocity. That's our unknown. So what we need to do is pick an equation that has all four of those things in it. Our equation is v squared is equal to, v final squared is equal to v initial squared plus 2a delta x. So our velocity here, our final velocity squared is going to be equal to, we're just going to plug everything in, 8 squared plus 2 times negative 2 times 7. So the final velocity squared is equal to 64 minus 28. So just going over here, final velocity squared is equal to 36. And so to get the final velocity, we're going to square root both sides. And so that final velocity comes out to be 6 meters per second. Now we need to draw our graphs. So let's start with the velocity graph. I have an initial velocity that's positive. I have an acceleration that's negative. So we're going to move in this direction. Now notice I still have a positive final velocity, so I'm okay stopping here. That's fine. Now for the position graph, I know we're going to assume we start off at 0. I know that I move forward because we have a distance of 7 meters, so it's going to be moving forward. We just need to know what it looks like. So I know I go forward, but here I have a negative acceleration. So one of the things that negative acceleration means on position versus time, and we'll draw it over here, negative acceleration on position versus time means some sort of frowny face. So one way we could look at this is to go, all right, I'm going to have a frowny face, or concave down to represent negative acceleration. The other way of looking at that is to go, okay, the initial velocity is positive, so my initial slope has to be positive. And we'll write that down. So the initial velocity is positive, so the initial slope has to be positive. And then the final velocity is smaller. So I have a smaller final velocity, and that means my slope up here is going to have to shrink. So if you do that with your hand, what you see is that nice concave down thing, which matches what we did before with our little frowny face. All right, number 2. A bus has an initial velocity of 12 meters per second. If it slows down to a final velocity of 4 meters per second over a distance of 8 meters, how long did the bus need to slow down? All right, so for this one, our givens, we have the initial velocity of 12 meters per second. We have the final velocity of 4 meters per second. Our displacement, how far we go, is 8 meters. And what we want to know is how long. That's one of my unknowns. But if you'll notice in this whole thing, we also don't know the acceleration. So this just turned into two problems. The first one is find the acceleration. So to find the acceleration, I want an equation that has all this stuff in it. V initial, V final, delta x, and acceleration. So to find the acceleration, V squared, V final squared, is equal to V initial squared plus 2a delta x. So if we plug in our numbers, we have 4 squared is equal to 12 squared plus 2a times 8. So if we multiply all of our numbers out, I get 16 is equal to 144 plus 16a. So I'm going to subtract 144 from both sides. Actually, I'll tell you what, we'll rewrite this. We'll rewrite this over here. Or just rewrite that whole line. 16 is equal to 144 minus 16a. So subtract 144 from both sides. Plus 16a. Sorry, so we'll subtract 144 from both sides. So that crosses out. And we get, when we do 16 minus 144, negative 128 equals 16a. Divide both sides by 16. And we get that the acceleration is negative 8 meters per second squared. Now, that's only part of my problem. That's the first part, find the acceleration. Now we have to do the second part. Find V final, find the time. So to do this, we have everything, and when we have everything, I like to use V final is equal to V initial plus acceleration times time. So we'll plug in our V final, 4 meters per second, equals V initial, 12 meters per second, plus the acceleration, negative 8 times time. So subtract 12 from both sides. 4 minus 12 is negative 8, equals negative 8t. So my time comes out to be 1 second. And there's the answer to our problem. Now we need to graph it. So for the velocity graph, we start off with a positive initial velocity, but we have a negative acceleration, which means the slope of the velocity versus time graph is going to be negative. And it's okay that it doesn't cross the axis because the final velocity is positive. Now, we're going to assume that we start here at the origin, and since we're traveling positive 8 meters, we're going to go forward. Now, looking at this, we know we have negative acceleration because we have negative slope. And over here, negative acceleration looks like a frowny face or concave down. So we could draw it like that. Or we could look at the slope of the velocity versus time graph, we could look at the velocity versus time graph and say, okay, positive initial velocity, so I have positive initial slope. So I have a lower V final. So up here I'm going to have a lower slope. It's going to flatten out a little bit for me. And then if we kind of connect those two, it gives me that. That's not a very good connection. If we connect those two, it gives me the same kind of concave down thing that we're looking for negative acceleration. All right, number 3, a crime scene investigator is looking at an incident where a truck skidded to a stop. So, came to a stop tells me something. That's my final velocity. By measuring the skid marks, he determines that the truck moved 40 meters while stopping. He also knows that the truck's acceleration is negative 20 meters per second squared. We want to know how fast the truck was moving before it came to a stop. So how fast was the truck moving before? So if we list those out for our givens, the final velocity, since it comes to rest, comes to a stop, is 0. The displacement is 40 meters, and the acceleration is negative 20 meters per second squared. Our unknown in all of this is the initial velocity. That's what we want to find. If you're a crime scene investigator, you're looking for the question, was the driver speeding? So looking at that, the equation we're going to choose has velocity, acceleration, and displacement. So we have final velocity squared equals initial velocity squared plus 2a delta x. So our final velocity is 0 equals the initial velocity, which we don't know, squared plus 2 times negative 20 times 40. So if we multiply everything out, we get 0 equals initial velocity squared minus 2 times negative 20 times 40 is 1600, so minus 1600. Let's write that down over here again. 0 is equal to v initial squared minus 1600. So 1600, if we add that to both sides, goes away over here, and I get 1600 is equal to initial velocity squared. We're going to take and square root both sides there. So my initial velocity comes out to be 40 meters per second. Now we need to make the graph. So as we make the graph, we note that our initial velocity is positive, so we want to put our initial velocity there, and then our final velocity is 0, so that goes down to 0, which is good because this graph shows, so we have a negative slope for this graph, which means we have a negative acceleration, which is what we want to see, which is what the problem gave us. And then for position, we're still moving forwards, right? We have a positive displacement of 40 meters, but we're slowing down and stopping, which means we have negative acceleration, so it's going to look like that. Or we could look at the slope of velocity. Look here where we have positive initial velocity, so over here we have to have positive slope. And then over here, final velocity is 0, so up here, my final slope needs to be equal to 0, which gives me that nice concave down shape. Number 4, a race car traveling at 48 meters per second slows to a stop in 72 meters. How long does it take the race car to stop? So with this one, with our race car traveling, oh sorry, I didn't circle how long. How long does it take the race car to stop? So my givens, the initial velocity is 48 meters per second. The final velocity is 0 meters per second. And the displacement is 72 meters. What I don't know, what I'm asked to find, is how long I need the time. But looking at all this, I don't have the acceleration. So my first step is to find acceleration. On that journey to find acceleration, we're going to pick the equation that has initial velocity, final velocity, displacement, and acceleration in it. So v final squared is equal to v initial squared plus 2a delta x. So we're going to have 0 is equal to 48 squared plus 2 times a times 72. So multiplying all that out, I get 0 is equal to 48 squared, which is 2304, plus 2 times 72, 144a. I'm just going to write that up here. So 0 is equal to 2304 plus 144 times the acceleration. We'll subtract 2304 from both sides. That goes away, so I get negative 2304 is equal to 144 times the acceleration. Divide both sides by 144. And when we do that, our acceleration comes out to be negative 16 meters per second squared, which makes sense because we are moving forward and slowing down. Moving forward and slowing down means negative acceleration. So we want to graph this. Looking at it, my initial velocity is positive, and then we're going to slow down and stop, so my final velocity is 0. So the velocity versus time graph is going to have a negative slope, which is good because we want the acceleration to be negative. For the position versus time graph, hopefully these are starting to look a little bit familiar. We're moving forward, so we're going to start here and end up above where we started. Since we have negative acceleration, we're going to have a concave down or a frowny face curve for that. All right, last one on this. A car begins at rest and accelerates at a rate of 12 meters per second squared. How long will it take for the car to travel 384 meters? So, for my givens, the initial velocity is 0 because we begin at rest. The final velocity we don't have, so I don't need to write that down. The acceleration is 12 meters per second squared. The displacement is 384 meters. And my unknown is the time. So I have to find an equation that has all of those things in it and nothing else. That is, delta x is equal to initial velocity times time plus 1/2 acceleration times time squared. Because the initial velocity is 0, that whole term goes away. So let's plug everything else in. We have 384 is equal to 0 times time. That's why that goes away. Plus 1/2 times the acceleration of 12 times time squared. So that gives me, let's write it up here, 384 is equal to, we don't have to write down that 0 part, 6 times squared. So I'm going to take and divide both sides by 6. The 6's go away. And time squared is equal to 64. So in order to solve for time, we're going to square root both sides. And time ends up being 8 seconds. So to graph this, we start off with an initial velocity of 0. So my initial velocity is 0. And then we have a positive acceleration, which means we're going to have a positive slope here. Positive acceleration means positive slope. For the delta x, we're going to start at 0, but we move forward. And since we have positive acceleration, positive slope on velocity versus time, we're going to have a smiley face here on position versus time, or something that shows positive acceleration. The other way we can do that is by looking here at the velocity. Initially the velocity equals 0, so initially the slope has to equal 0. At the end, the velocity is positive, so at the end we have positive slope. So my slope is going to have to change from a 0 slope to a positive slope.